So I was going to focus this first one on what we do, how we structure our Metcal procedures, and how we structure our drivers. Because what I do today in automation all came from how I was designing and structuring my drivers from 20 years ago when I first reached out and started building CalLab solutions, as well as I did when I worked back at the Intercal days. So what I want to do is with each one of these, I kind of want to make it a learning thing. So we always start up with the learning objectives, what we want the walkaways to be. So one of the things I learned is what I had done with Metcal as I put this structure together is I took the object-oriented programming principles where you're going to design things and build objects and build inner workings between your objects. And I would call it ravioli code is what I would call it. But how I took object-oriented programming approaches and I applied them into what we were able to do inside of Metcal. So, and then the other objective is this is kind of turning into Metrology Taxonomy, how we structured out these drivers and how they run. And the NCS 141 committee that I'm part of, we're working on building out a Metrology Taxonomy. So what we're doing with this taxonomy is we're trying to build out a library of all the measurements in an abstract format. So every measurement we do in the calibration lab, we want to build that into an abstract format so that we can start building things around it. And that's part of what you're going to do in an object-oriented environment is you're going to abstract things out to their core components, and you're going to start using those core components in reusable formats. So you in the long run, you have better structure to your code, and you're actually doing more code with less code underneath. So, and then we're going to kick out some sample code. So one of the things I tell people with code and how we do things in code is, and this is something that I learned when I came into writing software, is every line of code you write is a line of code you have to debug and support. So the task that we have as automation engineers, I believe, is to start writing less code and getting more reuse and more usability out of that code. That's kind of what we wanted to do as we were putting this together. So real quickly about, MII CalLab Solutions. So, we've been writing software since Intercal days, which is going to go back to like 1995, 1996 timeframe. So at the time I worked at Intercal, they had the world's largest library of Metcal procedures. And then at the time, I think CalLab Solutions actually has the largest library of Metcal procedures because of how many items we've put into it over the years. And we've done that with a small team. So we also acquired CalLab Magazine. So we're searching for articles in case anybody has been wanting to write a metrology-related article. So that's pretty much it about, us and CalLab Solutions. So I like to keep this slide in here because this slide makes a lot of purist metrologists very mad. So business efficiency is about doing things better, cheaper, and faster. And I got this better, cheaper, and faster when I was working with the guys out at Keysight when they were still Agilent Technologies, that even in the calibration lab at Keysight, that they have this business problem, that they've got to do things better, cheaper, and faster, and they're always under this pressure. And I bring this in because, when we start talking about cheaper and faster, we forget that better is at that top. So that doesn't mean we need to be less accurate. It just means we need to be more efficient in how we do things. So I think that applies out to anybody that's inside of the calibration business. Over time, you just got to come up with better ways to do things. So in software, one of the things I like to do all the time is start with a problem statement. So But before you go out and just start writing a bunch of software, get a good problem statement put together and get that problem well defined. And as CalLab Solutions and back in the InterCal days, we had a problem of we needed to write MetCal procedures, but we couldn't write a custom piece of code for every single one of our customers. So typically a MetCal programmer is going to grab a piece of code, he's going to copy it, paste it into a new thing, and start going through and making a bunch of changes. So we saw that as being a problem because now when you do that, you copy something, you have to go fix it in several different places. And we had to minimize the amount of fixes we had to do in calibration or inside of our procedures because the cost of calibration or the cost of software, when you look at a lot of the statistics of it, 20% of your cost is going to be developing the software, developing the first version of it. 80% of the cost is going to be maintaining and supporting it over the lifetime. So every time you're cutting and pasting code and copying it and editing it, you're creating more and more work for what you're going to have to do in support. So we saw that as being our problem statement and bringing it down into better, cheaper, and faster. We needed to have highest quality of code. We needed to control our costs. And we need to get our development time down to being less than 10x the manual cal time. So we ran these numbers when I was at InterCal. And when we started out, any new procedure, it would take a developer 20, 30 times the calibration time, or the 20 times the manual calibration time would be how long it took to write a procedure. So if you look at something that's a 2-hour calibration, it's going to take him a full week to write that automation. And we need to get those times compressed. We need to get those times down because we're competing with the self-maintainers who want to write their own code. So that was the business problem as to how we started this. So any questions about the business or the problem statement? All right, I will continue on. So what we started doing at InterCal and what I continued doing at CalLab Solutions when I broke out is I sat back and started building this structure of building procedures to where our procedures have less code. And the thing that we do is we write one procedure that's going to control the test points for a unit under test and the cal process for the unit under test, and we extracted the drivers and how we communicated with the drivers out of that. So overview of this is we made our main procedures. They're going to be UUT specific. Their jobs are to identify the UUT. They're going to organize the execution order of the procedure, and they're going to organize the output, how the data is presented to the user. And we're going to come in and call the test points routines. So they're going to read the test points. So we get reuse of test points. So if we're doing a multi-channel O-scope, we only have one place where we keep all of our channel measurements. And I put the spaghetti code thing on one side. So you can look at a typical procedure that I'll see a lot. Start following those blue lines and how those blue lines jump around. Versus the structured code, it's easier to follow what's happening and when it's happening. So that was kind of how we wanted to put together our procedures, is we wanted to make it very easy for somebody to put up a procedure and see how we're going to execute it, and then also be able to see how the results are getting printed. So that was something that the main procedure does. When we reach out to the test points, again, our test points are going to be UUT specific. So we're going to list all the test points that are in there. They're going to evaluate the pass and fail of that device. And they're going to call the test routines sub-procedure. And inside of the test routines procedure, again, it becomes UUT specific. And what we're going to do there is we're going to send commands out to the UUT. and we're going to generate some generic commands that we're going to send out to our drivers. So instead of coding in a specifics to a 5500 driver, we're going to call out what the function capability is we need out of that driver, and we're going to put it together in name value pairs and reach out and call it. So then our test routines are going to call our SubConfig, which becomes very specific to the customer or the workstation that we're working with. And there we're going to give the connection messages. We're going to call specific drivers. And if we need to do some measurement uncertainty overrides or configurations for that customer, we would handle it there. Then we're going to reach out to our drivers, and our drivers are going to be standard specific. Their job is to translate that generic message into the instrument specific messages that go with that, as well as calculate the measurement uncertainty that driver's running. So what we get out of this, and there's an example procedure if anybody wants to go out and grab this. There's an example procedure out there at store.callabsolutions.com. Some of you guys may have already downloaded this. It's absolutely free. Keysight had us write this about 6 years ago. So, but you can pull it inside of that free procedure. You're going to get a 5520 version, a 5820 version, and a 9500 4-head version of that. But what I want to show in here is that our main procedure, our sub procedure, our test point procedure, and our test routines procedure, those are all UUT specific, and they stay exactly the same across all of those configurations that we have. So our procedure, our core procedure, our UUT side of the code never changes based on the standards that we're using. So it allows us, instead of having 4x the amount of code, we have about 2/3 to 1/3 the amount of code we need to support in just that configuration. So, and it also allows us, the configuration that we have is these right here might be able to be contained inside of an OCal FSC. But what you can't do with an OCal FSC is you can't replace your 5520 scope output with the 5700, do your time marks with a 33250, and your bandwidth checks with a PSG E4419 and E9304. There's a typo there. It's not a 9340, but you can't do it with a 9304 power sensor. So that OCal has that problem of how it's put together, that it doesn't allow you complete flexibility in what you're going to do. It's all tied into somebody's original paradigm as to what the flexible standard should be. And that's what we wanted to overcome as we were putting this together, because everybody builds their standards and their drivers very, very differently. So a little light dive into the code. So this is out of our main procedure. And you can see by the line numbers that I've cut and pasted and chosen the things. But you can see we're going to run these tests. We're going to do channel 1 DC vertical gain. And then once we've completed that, so we're going to jump from here down, we're going to run these tests. And once we're done, we're going to jump back up to this done. So that's how we go in and we control how we're going to run the order of execution inside of this scripting language. So every time you come in it, this is like a great big case select, you could think of it, or a sequencer. It's handling the order that we're going to run things in. And there's places in there that you'll see that we've got if statements in there where we're only going to run channel 3 and 4 if it's a 4-channel oscilloscope. So those are in there. And then also here, we're setting up variables. And I know one of the questions people are going to have is, why am I using S registers and mem registers? And the reason for that is we were using this technique back in the 4.0 and 5.0 versions of MetCal, back before named variables were ever added. So we wanted to keep our procedures to where they're backwards compatible. So that was one of the requirements we had, is we didn't want to write everything to the current version of MetCal. We wanted to be able to go back and be backwards compatible, because I was surprised to find out that companies over in Europe are still running MetCal 7.3 because of limitations that they have with the character set they have. Their extended character set in Europe doesn't support the old way they wrote MetCal, so they would have to come back in and rewrite all of their procedures. So backwards compatibility was very important for us. So, and then here you can see we're just calling the test point sub. So inside of the test point sub, as we jump into it, we've got a section up top that we're going to run like a case select, and that's just going to look at the name that's in 24. It's going to grab the channel number out of S24. It's going to look at the name, and it's going to jump down to the DC vertical gain test points. Once we jump down to the DC vertical gain section of the code with the data points, and the reason we do this, we put this great big sequencer at the top. The reason we do it was there was a limit to 8 lines inside of a MetCal instrument lines. So if we had a test, if we had a subroutine that had 9 or 10 calls that we needed to make, we couldn't put that inside of the instrument line. So we just chose to put a case select at the top of that and actually jump down to the pieces of code we were running. So this is going to come in at line 1. Then it's going to find that it's a DC gain, and it's going to jump down to line 9.002 and start executing that code. And you can see in here we've got the evaluation. So we've got to be 0.8 volts, 35 volts plus or minus 0.8 volts to pass that test. And you can see in here where we make out to our routines call, we're going to make out an init call, which is going to run any steps we need to do before we can run that calibration. So if I needed to zero and calibrate a power sensor, I could do it in that init function. Then as we come down, we're going to set up our memory variables. So we're going to set the M2 is going to hold the volts per division setting, and M1 is going to hold the voltage we need. And then we're going to call this driver that's going to go out and do it. And we're going to configure up our standard. We're going to get back our uncertainty, have our ACC statement. Then we can come in and make our measurement call that we're going to run. And then we can come back in and evaluate pass and fail. So now as we get into the test routines driver, again at the top, we have that section that's going to be a sequencer, or that's going to be our case select, and it's going to jump down to the section of code that's going to run our measurement process. So here, the first thing we do is check our connections. Okay, so now what happens with the checking the connections and putting the connections where we check the connections with every state, that's going to allow us to halfway through the process, because of customer A's configuration versus customer B's configuration, we could go in and handle something like a frequency change inside of the driver. So they might need to use 2 signal generators to cover the full frequency range of this. This allows us to, at any point in the process, go make sure we've got the connection that we need to run that section of the process. And then here in the configuration, we're going to store in an S26 the configuration we're in. So we're DC gain channel 1. And inside of here, you can see we're resetting the device under test. Here we're resetting our DC voltage source. And inside of this section of code, we would put any commands that we don't need to send each time to the instrument. So we'd set our time base, our trigger configurations, and other things we would set in there. And then we would come back in and start running additional tests. So then we're going to set the variable here to S26. So that means we're only going to run that section of code the first time. Now in the test routines below there, you can see how we take that generic, or we take that M1 requirement for DC voltage, and we're going to push it into a source volts DC where volts equals 1, and then we're going to call our SubConfig, and we're going to pull our uncertainties out of it because we want to do some things with the uncertainties there. And then in our measurement process call, here we're just going to query the measurement off the device, and we're going to calculate or do our U3 sets. So we're going to get that out of the device where we can get our statistical values, because we set it to, I believe we set it to 64 or 32 measurements. So we don't have to take multiple measurements. We can just ask the unit under test to give me your standard deviation, and we can start using that. Then down here, we're going to push back our measurement uncertainty out of L9, and we're going to push back the value that we read from the device. So that's going to get pushed back to the device, or back to the test point sub. So now we called the config sub, okay? And then this is where we start getting some nice uniqueness in what we're going to do. So inside of our SubConfig here, we have, again, a section that's going to jump us down with our case select, and we're either going to check our connections or we're going to call our driver. And we're just looking at what's in our S30, what's in our command. So we can make that assumption. So here, if we're using a 9500, you can see here that we grab that M20 and we tell it the channel that it's going to run on the 9500. So this makes it very easy for me to convert a procedure from a single 9500 to a multiple channel 9500 just by adding this channel command to the driver when I send it off to the 9500. When we look at the configuration for a multi-channel driver, we can see that if we got a 4-channel, here's our 4-channel connection. If we have a 2-channel, here's our 2-channel connection. And if we had a 1-channel connection, all I'd have to do is put in the 1-channel connection for the 9500. But I have that example here in a 5520 driver. Okay, so our 5520 driver, we're going to have a single channel connection. And inside of the driver, we're just going to call our 5520 scope output driver straight up. So we don't have a lot of variation in our UUT code that gets us into something that's standard specific. So that allows us to have something that can easily jump from a 9500 single channel to 2-channel to 4-channel configurations. Then inside of our driver, again, we've got a little selection thing up top based on what the command is. But you can see here how we come down and we parse out the channel. And then here we're going to parse out the voltage. If you didn't give me a voltage, I'm going to give you an error that says, hey, programmer, you got to tell me the voltage you want me to set it to. Then here we start checking that our voltages are within the limits of the calibrator. If the voltages are not within the limits of the calibrator, we need to throw up an error that says, hey, Mr. Programmer, you got to go back in and update this file. So then we can jump right in here to or jump down to our test routine or our driver where we're going to set it up. And you can see how we're going to route the signal. We're going to set the function to DC, set the impedance. We're going to check our ground if it's on or off, because 9500 can't put out voltages below a certain amount. You have to short the output. And then we're going to turn our output on. Then we're going to come in here and check our 9500 to see if it has any errors. Here, we're going to come in and look up the accuracy of that 9500. We're going to stick it up into L3, and then we're going to pass back the value that we had and the uncertainty. And then here, we're going to do an expansion of our uncertainty. So we're going to add our standard resolution, and we're going to make an assumption that our standard was calibrated 4 times more accurate than what it's putting out. So now we can expand our measurement uncertainties if somebody was trying to do an accredited calibration with us. We'd get a little bit more uncertainties. And then here, this would be where in the main procedure, or in the subconfig, we could go put in special things that customer may need to override these T-sets for their uncertainty values. So now jump back into the main procedure, or the test points sub, and you can see that we're going to parse out our uncertainty. We're going to stick that in L9, and we're going to put that in our ACC file, and then we're going to reach down in here and grab out of MIM and stick it in for our MIM compare. So any questions on the overall structure of how we put this together? I'm thinking most of the people in here have seen our procedures, downloaded and ran these. So I want to jump back to what we're doing with the MII Group and what we're talking about doing inside of the MII Group when we start looking at how we're going to run these configurations. Is the MII Group is looking into how we're doing this with the drivers, where we're talking about something very generically like source volts DC and then source volts AC. And as we're doing these things, we're figuring out how to build these standardized ways of doing these configurations to where any device that can source DC voltage can actually be used in place of this. So here you can actually replace inside of your configuration file, you could replace it with a driver that's a power supply that's monitored by a voltmeter. And the voltmeter and the power supply are going to continue in a loop until the voltmeter reads 35 volts out of that power supply, and then comes back and returns you the value of it plus the uncertainty. So it allows you to have these multiple ways you can come in and do these things. So it's an idea of having a thing that's an abstract definition of source volts DC into a specific technique implementation. And this is what I've been working on for the last 20 years. And from MetCal to Metrology.net, I see that there's a lot of correlation. There's a lot of value in how we put this together. So now with the MII Group, we're trying to redefine it and configure it a little bit better. So if you go out to the Metrology.net website and you click on the Metrology Taxonomy, you can see a list of all the taxonomies we've been working on. And you can see down here under source that we have a source volts DC. And then this gives you an idea of how we're putting this together. So if you're going to talk volts DC, you have to tell me the voltage, and you can optionally tell me the impedance and maybe what's your UUT requirement. And the process should always return back the voltage. What we learned is we can't go, and this was my mistake, so when you look in my code, it's going to be talking about source volts AC. But you see when we start talking about source volts AC that we got a problem, that we have to actually tell what that AC voltage is, because we don't know from just source volts AC. We can assume that it's a sine wave, but we don't know if it's a triangle wave. We don't know if it's a square wave. We don't know what that AC signal is. So these are things we've been working on with the MII Group to get a better definition of how we can create these abstractions to how we can build things that become more interchangeable so we can write less code to do our work. So I think I've hit all the learning objectives. I don't know if anybody has any questions about the object-oriented programming approach that we did, or the MII, what we're trying to do, creating this metrology taxonomy.
Hey, Michael, this is Miguel with DressCal. Got a question for you.
Yeah.
Hey, so real quick, with respect to how MetCal is configured, are aliases added? So say, for example, you're using one standard as a DC source voltage and DC source current. How does that look like when you configure it? Do you add it as like an alias, or?
Yeah, so we add it in as an alias, but we're handling the flexibility with the drivers. So when you look at our aliases in here, we're going to use at 9500 as our alias. So you can use any aliases that you want inside of that driver. And then the newer versions of MetCal will let you have multiple aliases. But the problem with doing it inside of making it a DC voltage source is going to be then you can only have one DC voltage source.
Right, that's what I was wondering about, because you know, one particular calibrator would be capable of sourcing different parameters, and I was just wondering how you're addressing that using this method.
Yeah, so how we address that with this method is I'm going to pull up Vault if I can. And I found the best tool out there to use was a system called SourceGear Vault. So how we address that, and I'm going to jump up here to something that's going to be just our DC voltage drivers. So here's all the voltage DC drivers, and you can see in this directory I haven't put that one in, and this one's old. But what we did when we look at the 5500 is we created two drivers. So we've got actually three. We've got a 5500 normal output, a thermocouple output, and a scope output, because each one of those things can source DC voltage. So when I was at Intercal would try to make one driver that did everything the instrument did. And that made it hard to debug and support those drivers. So when I left Intercal, I changed my model to where each driver supports one standard and it supports one output on that standard. And then I do all of the interchangeability at that subconfig level. So when we jump down to this 5520, and I'm going to look at this guy, I think I can diff this versus another one. So yeah, this will let me do that. So I'm going to diff these two files here. And now you can see what the difference is between the two. So this guy's calling the 5820 and this guy's calling the 5500 scope output. If I wanted to change that driver, if I wanted to change it to the normal output, I would just put a normal output driver in here, and I'd call the 5520's normal output. And then here you can see that this guy has to add to it. So this guy has to add the channel configurations to it, because the 5820 will do multiple channels. So here I'm calling the level sign function. So it's that one function on that one output of that scope. So that's how we're handling the variations with the configuration, is we're handling it, we're using the native FSC or the native configuration that you would use for the driver call. And then we do the exchange in the config with what driver we're going to call when. Does that make sense, Miguel?
Yeah, it does.
So, and it gives us a lot of power. And anybody out there that's writing MetCal procedures, I highly, highly, highly recommend you look at SourceGear Vault, because what I'm able to do in here is I can look at this 5520 scope output, and I can right click this and go into properties, and I can look at all of the shared links. So that's every procedure that's using that version of that driver. The other thing I'm able to do is I can come in here and I can say show the history. And now I could come in and say, hey, there's a problem with this change that we made. So you can see we've got a version 8 in this directory versus version 9. So I can come in and I can look at this and I can diff these two and say, what's the difference? Oh, I changed it from a V set to a T set. Well, say this instrument needed, this driver needed this version for whatever. So I can right click this and I can pin that version, and that directory will always use version 8 of that driver. So it gives me a lot of power in what I can do in controlling things. And Visual Source Safe is the only tool that I've ever seen that lets you share files into different directories. So if you're MetCal 8 programming, where they're kicking back into the packages, where you've got a package for everything, what I see as a problem in there is each one of those MC files, when you take your master directory of MetCal procedures and you convert them down to PXEs, what I see is every one of those shared files, now you've got another copy of it. So, and this allows me to share my shared files, but I'm keeping one version of them in all the different revision controls. So any other questions?
I'm good, Michael. Thank you.
Yep. Kick into the question sections. So I do have questions out for you guys. I wanted to get some ideas as to what you guys want to see in future and things that you have interest in for automation lunch and learns.
Probably best to send out a poll to everybody that attended, because at the moment I don't have any.
Good idea. And then if anybody wants to go out who doesn't already have it, grab that free procedure. We've moved over to a new tool for our procedures. So knock on wood, I haven't tested it yet, but I believe when we go out and push updates in that it'll actually notify everybody who's registered that there's an update available.
So will any of your lunch and learn be focused on metrology.net?
Yeah, I'm thinking about doing some on the metrology.net. I don't want to make the lunch and learns that they're all about, selling somebody's particular product. So I want it to be, that there's a learning objective and whatnot. But yeah, we could do some around some of the things that we've done in the metrology.net and how we've put that together.
Right.
All right. Well, I appreciate you guys taking the time, and we have one scheduled for 2 weeks, so I'll poll everybody to see what we would like to talk about at the next one.